So today we're going to talk about live container migration, the ability to move a container from one node to another. So I'll kind of get into that and what that actually means. So who am I? Field CTO at SREday, was employee number 28. I've been here basically since the beginning of the company. Husband, father, engineer, manager of people, farmer, depending on the day. You could see me with a lamb last year and me with my 4 daughters at our daddy-daughter dance, which I usually have the most dates. Victory there. So what is SREday? SREday is a Kubernetes automation platform. That was our core product. We're actually branching out into cloud resource optimization and actually moving into on-prem as well. So basically, we're using machine learning and analysis to optimize your actual resources. Sometimes that actually means paying a little bit more. 95% of the time, it means paying less and being able to actually use less resources. But overall, it's making sure that you're using the right resources for what your applications need and paying for the right resources. So this is an idea of what, before and after looks like. On the left-hand side, you can see the kind of the yellow line. So that's what the applications are asking for throughout the flow of a typical seasonality day. The blue line at the top is what you're paying for, right? That's the actual VMs, the instance types that you're paying for in the cluster. On the right, that's what we want, right? You want just-in-time capacity. You want the instances you need, the right sizes, the right shape, the right mixture when you need them, but not when you don't. So you want to make sure you're getting the most value there. So what happens when you have legacy applications? I love to rip on Java Spring Boot. I used to write a lot of Java Spring Boot early in my career. Sometimes they take 15, 20 minutes to boot up, right? You've got tons of libraries to load. They're huge monolithic applications. Probably everybody in this room has some type of a Java Spring Boot application if their company is older than 10 years. And it's likely not very Kubernetes friendly. Somebody at some point in time might have said, hey, let's modify this and modernize it. And they stuffed it in a Kubernetes container, stuffed it in the cloud, and they said, hey, look, it's cloud native now. But you can never move the darn thing because it takes 20 minutes to start up. That's a big problem. Machine learning jobs is another one. Yes, they might be relatively stateful and have some ability to restart, but if it runs for 10 hours and dies after 8 and it has to restart the 10-hour run, okay, great. You can recover it, but you just lost 8 hours worth of work. And another one is just stateful workloads, right? You've got Redis. In-memory caching, cool. It gets moved from one node to another. Now you have to rebuild that whole cache. Maybe not a critical thing, but your application is going to run slower. You have to rebuild all that. All these are problems with Kubernetes and being able to effectively bin pack and right size and move things around and do that just-in-time graph, right? If you have stuff you can't move, it's very hard to get to this state where you can actually optimize. So this is some examples of stateless versus stateful, like what we talked about before. Stateless, you think perfect state of the world, modern applications, Golang, microservices, they can move around, they can start up at an instance notice. The containers are 12 megs, good stuff, really nice stuff. That's not what most people have, right? If you're a startup, you're less than 5 years old, you might have a good amount of that. But I've even met startups where they hired a bunch of people who knew Ruby, they wrote everything in Ruby, and it didn't scale extremely well. Sometimes Ruby does, sometimes it doesn't, depends on what Ruby you're using, but you try, but it's also hard to get there. Stateful, all the examples we talked about before. Sometimes it's stateful because it has an in-memory cache that's ridiculous. Sometimes it's stateful because it's using a PVC and it's got a volume that's backing it. There's a lot of different things that make applications stateful and generally hard to move, and it makes scaling them very difficult. So this is an example of a customer that we worked with to right-size their environment and work to save them money. But they had a lot of stateful applications. They had stateful sets spread throughout all of their cluster. So you can see here, the blue shaded area is how much their applications were requesting. So that's how much they wanted to, how much the applications needed or asked for capacity. The green line at the bottom is how much they were actually consuming for resources. So what they were actually consuming on a day-to-day basis. You can see where we actually right-sized the applications. So we brought the requests down closer to the usage and made sure that they were asking for what they needed. But that top blue line at the very top, that thin blue line, that's what they were paying for. So that was the provision capacity in their Kubernetes cluster. You could see it did go down some, but didn't go down nearly as much as what the actual request went down. That's because there were a lot of stateful applications spread throughout the whole cluster, preventing it from scaling down effectively without causing interruptions to those services. There's some workarounds for this. You can try to segregate stateful away from stateless. That helps. You end up basically creating almost like a subcluster within your cluster. You create a node pool, stick things off to the side, cordon those workloads off to the side, and you say, okay, my stateful stuff's going to stay off over here. I'll optimize it one time, I'll take a maintenance window, and then I'll just leave it alone. That's not a terrible practice. You still have a lot of issues that you have run into with that. For instance, when you do that, you still have to update your nodes, right? I've actually seen companies where they wouldn't update their nodes. They were running 8, 9, 10-month-old nodes because they refused to interrupt those stateful services. They didn't want it. They had zero downtime. They couldn't take any downtime. Great. You're running a 10-month-old version of Kubernetes and a 10-month-old patches on your operating system, and you've got massive security holes, but sure, you didn't have any downtime. So that's a way to handle it. Not the best way, but it's when you're cost effective, it's a way. Other than that, if they're spread throughout your cluster, you either have to take downtime or be inefficient. Those are your choices. So why live migration matters. So now we get to actually the point of the topic here. 6 minutes in, not too bad. Because stateful workloads cause such a tremendous burden on being able to actually just-in-time right-size Kubernetes, we need to be able to move those containers without causing downtime to customers, without causing interruptions, without losing data, without losing TCP/IP connections. All of those things are critical when we're talking about being able to properly right-size a cluster with those kind of containers in there. Live migration can take a container from node 1, move it to node 2 without any loss of data, state, or TCP/IP connection. So what that means is when you have that stateful Redis service and it has this huge in-memory cache and it's serving things out, you can move that from one node to another without actually interrupting the data, without interrupting the TCP/IP, and without losing that in-memory cache. That's huge. You can run a Spark job on a spot instance. It can run for 8 hours. The spot instance gets interrupted. You can now migrate it to another node, keep the state that it's at, keep that 8 hours worth of progress, and then migrate it back to a spot instance. So it allows you to swap pods around. This is hugely important. So making sure that you have uptime, right? Making sure that you always have that continuous uptime, making sure that your connections don't die, making sure that everything stays up and running, super important. Even if your application doesn't stateful in the traditional sense, sometimes moving things around, you get disruptions. If you get a lot of spot instance interruptions at a time, you can lose some state even on your ephemeral applications. So this is the basic concept from a block diagram perspective, being able to move your pods from one place to another. So you've got your shared data storage. Sometimes that might be an NFS backing. Usually it's a PVC backing. If pods are PVC backed, you do have a slight delay on the migration because you have to do a PVC unattached reattach. And that takes time with the APIs and everything. Not terrible. You can still maintain all the state, but there's a slighter longer pause. If you're not PVC backed, if you're NFS backed, slower, but it allows you to do multi-read, multi-write. You can do it instantaneously on stateful stuff with NFS backing. Other workloads that aren't disk backed can be effectively instant, moving from one node to another. Demo time. Now, I've got quite a bit of time left, so I've got 2 demos that I'm going to run through here, 2 different use cases. One is Redis, one is Spark. This is a live demo on a live EKS cluster. I will give the caveat there that I'm in front of a room of, 60, 80 people, and I'm going to be running a live demo. If things blow up, I apologize. This is still an early release feature. So here we go. Give me like 30 seconds to queue everything up. Okay. That didn't take as long as I thought it was going to. Good prep. So we're going to start with Redis. Being able to move a Redis container, not backed by a PVC, not backed by ephemeral storage, not backed by disk at all. Everything is in memory. So I'm going to set the mic down here and do some typing. I'm going to check a couple of the keys that I already set in this Redis server. All right. So we have our SREday key. We have our Mandy key. So Mandy is the best, and PagerDuty should work with Cast AI. Where's Mandy? I told her I was gonna. See. All right. So we got a couple of keys set in here. We could do a lot more, but it's tedious if I set 500 keys in here and try to make you guys watch all of them. So what we're doing right now, we're on this Redis debug pod over here. I'm just connected to the Redis server that's over here. It says clone 1 on it because I've already moved this once because I tried this about an hour ago just to make sure things weren't going to blow up. Doesn't guarantee it's not going to blow up now, but better odds. So right now I'm going to go and trigger a migration. Yes, this is a manual step today. It's not entirely baked into our product. We can evict pods and be able to live migrate them, but the manual process is easier for demoing purposes. Let me go find my Redis pod here. So here's my Redis server pod. So right now we are on, let me find what node we're on here. We're on 106, 109, right? We're actually on the same node as the Redis debug pod, handy enough. So now we're going to go and trigger the migration, and we're going to move to node 111.217. I'm going to maintain TCP, and I'm going to run page serve. Migrate. So we create a clone 2 Oh, where'd my clone 2 go? Okay, no, it worked. So we do get Mandy. We do get SREday. So we actually dropped the clone on this one. The clone stayed there. All right, hang on, that actually didn't work. Let me do it again. Sorry. The dangers of live demos. Okay, so we're gonna set a new key so that I'm not smoke and mirrors on you guys. Last time I did this, and when I did it the second time, it worked. So bear with me. Oh, by the way, what node are we on? We're back on 106, 109, actually. All right, so now we're gonna go back to 111, 217 again. Migrate one. Okay, it's gonna give me a hard time. It's not working today. Typicals of live demos. Let me switch to my Spark work job, and we'll actually get that one working. So Spark, I know. This is the danger of doing this. It worked like an hour ago. Okay, let's try it on Spark now. I'll go back to Redis if I have enough time at the end. Okay, so we're launching a Spark job that will calculate the digits of pi out to, I think it's around 20,000, something like that. So you can see the drivers coming up. Once the driver's up, I'll go ahead and tail the logs. All right, so let's check the logs on the driver. Okay, driver's running, executor's coming up, container's creating. Okay, container's running. So now we're on 151, 118 for this one. We'll wait till we start processing work here. All right, so now we're processing. Now let's go to this one, see if this one works better for me. All right, so there's the Spark executor. We're gonna go back to 106, 109, migrate. Okay, so container created, clone one. We did not stop the job. We did not lose any data. We maintained state. We kept processing. The logs kept doing it. The driver and the executor stayed in contact the whole time. So that one actually worked. So if you guys want, I can go retry the Redis one. I did have it working, like I said, about an hour ago. We're working with 2 launch customers today. Spark is our first supported, fully officially supported thing that we're working on because Spark is so compute intensive. Being able to run Spark entirely on Spot is tremendously valuable to these companies, but you can't have a job that's running 8, 10, 12, 14 hours and get interrupted part of the way through. The plan for that is you'll have a big Spark cluster. Maybe it's 60 or 80 nodes of on-demand, or of Spot instances rather. You'll keep maybe 5 or 10% of your cluster as on-demand. It'll be cordoned, it'll be off to the side, and it'll be protected. If you get a Spot interruption, you use that side space like swap space. You move those jobs into the on-demand nodes, you bring up a new Spot instance, and then you live migrate it back to the Spot instance. That allows you to swap in and out of Spot and on-demand, so you can run everything in Spot, but be able to have some cordoned off safe space that you use as swap space. So now in the course of running a massive Spark job, 60 nodes plus across 10, 12, 14, 16 hours, the odds of having a job get lost and have to start over are not zero. You could have 10 or 12 nodes get interrupted at one time. You don't have enough swap space to handle it. Takes time to spin up new nodes, but it drastically reduces that. So now instead of having to run that on entirely on demand or having jobs getting restarted many times throughout that long run, now you can run almost entirely on Spot. Coupling this with some of our other features, like selecting the right instances, we're actually working on a feature where we can load balance across different AZs and possibly even across regions. That's going to give you a tremendous amount more power to use Spot instances, leverage Spot instances in production on these more stateful services. For instance, we talked about the Java stuff earlier. You can see we finally finished. Good stuff. When we talked about Java earlier, the Spring Boot applications, a lot of times those big monolithic applications can only run one replica. And there's a lot of Java Spring Boot out in production today running a single replica on some 16 core, 60 gig capacity that can't move. And so everybody just works around it. You stick it on a node, it's stuck in your Kubernetes cluster, everybody hates it, the DevOps guys all hate it, but you just work around it. Now those are going to be very easy to move around the cluster and be able to treat as if they were stateful. This also opens up the options for doing workload right sizing. So a lot of times when you have to do workload right sizing, today up until Kubernetes 132, they just launched in beta in-place right sizing. It only works for downscaling. They removed the ability to upscale because they had too many edge cases around it that was causing bad behavior. And it's still in beta flag. I haven't heard if AWS, does anybody know? Did AWS actually approve the beta flag? Anybody on 132? Nobody knows? Okay, I don't either. We've tested it in alpha. It works on the downscaling and stuff, but you have to be able to stay on that node. This is going to allow you to both upscale and downscale requests on your application without losing your application runtime. So as you start approaching your requests on your memory and you're looking like you're going to breach, we can then move that pod to a new node before you kill out and crash that pod on your request. So now we can adjust the actual requests and limits on those pods before they have actual issues with performance, before they start crashing, before you end up with performance issues. So this is going to unlock a whole world of new abilities of moving things around within Kubernetes and new abilities to optimize and best use that space. And I'll toot our own horn a little bit. This is probably the most disruptive thing I've seen come to Kubernetes in my career, because this is going to allow Kubernetes to be used for all applications. Love Kubernetes because they build for it. Fortune 100s, Fortune 500s didn't build for Kubernetes, right? Anybody that's older than 10 years has applications that are not Kubernetes friendly. This makes everything cloud native and everything can be Kubernetes friendly, which is super powerful.